In this video, we will talk about how to convert decimal numbers to binary numbers. So I have three examples for us to work through here. Let's check out the first one. Let's say we have the decimal value 43. How can we write this in binary? Well, remember, binary only uses ones and zeros. So the first digit in a binary number corresponds to 2 to the 0 power. The next digit from the right corresponds to 2 to the first power. The next digit is 2 to the second. The next is 2 to the third, and on and on and on. So what is 2 to the 0 power? Well, that's just 1. 2 to the first power is 2. 2 to the second power is 4, and 2 to the third is 8. So if you'll notice a pattern, we start at 1, and we just double each successive number. So the way that we can write 43 as a binary value is we need to start at 1, and we need to double numbers until we get to a number that's greater than 43. So for example, let's make a little room here. We said we'll start with 1, then 2, 4, 8. 8 doubled is 16. 16 doubled is 32. 32 doubled is 64, so that's too much, so we don't need the 64, so we'll only go up to 32. And now we'll say, which of these values can we add together to get 43? Well, we'll have to start with 32, so let's underline that. If we do 32 plus 16, that's 48, so that's too much, so we're not going to use 16. So we could do 32 plus 8, that's 40. If we do 40 plus 4, that's too much, so we're not going to use that. But we could do 40 plus 2 plus 1. That would get us exactly to 43. Now here's the trick. Any number we underline gets a 1, and any number that we don't underline gets a 0. So 43, this decimal 43 as a binary number is 101011. This is our final answer. All right, let's try another example. Let's say we want to write the decimal 139 as a binary number. How could we do that? Well, we'll use the same trick where we say let's start at 1 and let's write numbers that double until we reach a number that's greater than 139. So 1, 2, 4, 8, 16, 32. 32 doubled is 64. 64 doubled is 128. 128 doubled is going to be a number that's greater than 139, so we only need to go up to 128. And now we ask ourselves, well, out of these values, how can we pick values that add to 139? Well, we can start with 128. We have 128. How many more do we need to get to 139? That would be 11 more. So what values remaining add to 11? Well, we could use an 8 and a 2 and a 1, since these three are 11. So 128 plus 11 is exactly 139. So remember the trick. Any numbers that we underline, they get a 1. And any numbers that we did not underline, they all get a 0. So 139 as a binary number would be 10001011. That's our final answer. All right, let's try one more example. Let's say we have the decimal value 350. How can we write this as a binary value? Well, once again, we'll start with 1. And we'll start doubling it until we reach a number that's greater than 350. So we'll say 1, 2, 4, 8, 16, 32, 64. 64 doubled is 128. 128 doubled is 256. And 256 doubled would be 512. So that's too much. So we only need to go up to 256. So now again, we're asking ourselves, out of these numbers, how can we pick numbers that add to 350? Well, we'll start with 256. So 350 minus 256. Let's see what that is. Minus 256. So 0 minus 6 we can't do. We'll borrow here. We'll add a 10. 10 minus 6 is 4. 4 minus 5, we can't do that. We'll borrow here and add a 10. So this becomes 14. 14 minus 5 is 9. 2 minus 2 is 0. So we need 94 more out of these values right here. So 128 is too much. We could use a 64. So if we have 64, to get the 94, we need 30 more. So 32 is going to be too much. So what about 16 plus 8? That's 24 plus 4. That's 28 plus 2 is 30. So this gets us exactly to 350. So remember, the values that we underline, they all get a 1. And all other values that we did not underline, they get a 0. So our final answer is 10101110. That is what 350 is as a binary value.